And now the thing that you've been waiting for, which is colon notation, how to extract from a larger matrix, right? Let's take a look. We'll just call this, we're going to call this A1. Okay, so we'll call this A1. Sorry about my handwriting. Okay, and we'll use a larger matrix this time. We're going to do 1, 2, 3. And we'll do 4, 5, 6, 7, 8, 9. Okay. So if we did that here, sorry, let me just replace that. That's better. If we did that here, what's going to happen is sometimes I may want to extract certain pieces of this matrix and build my own little matrix or vector or row vector, column vector. And the best way to do that is using colon notations. But it's important to understand how to use colon notation. So let's say we do the following. We say we'll say A of 2, I'm sorry, A of 1, right? Because that's what you're referencing, right? The name of the matrix is A1. So we want to reference A1. We want to extract the colon using colon notation. And let's say I want just the first row. Okay, just the first row. So the first row is obviously the first parameter in this colon notation function. So the colon, so let's do that. Let's do that here. Means that we are going to extract all rows, but in this case we don't want all rows. We only want the first row. So we can say, and keep that in mind. Okay, I kind of put that in your head, meaning all, right? So colon means all. Because we only want the first row, we want row 1. But which columns do we want? Do we want only the first column, the second column? Well, I want this whole thing, right? I want this whole thing here. So that's where colon notation comes in. So I can say colon, colon. And what this is going to give me is it's going to give me a row vector that looks like the following. Okay. So essentially what I would do in MATLAB is I would say, let's call this A2. A2 is equal to A1 of, give me the first row. This keeps doing that, I don't know why. Give me the first row and all columns. Okay, because you need all columns for the first row, right? And then do semicolon. And that should give you this thing here. Simple enough, right? Simple enough. Let's look at another example. Okay, so let's continue with another example. Let's take a look at, we'll use the same matrix. So what if I wanted this matrix here? Okay, so I want 1, 2, 4, 5, 7, 8. So what I need to do is first, how many rows am I getting here? How many rows? Okay, so it looks like we're getting all rows, right? There's 3 rows and we're getting all 3. So what happens when you want all? Colon. Right? Colon notation allows you to get all. Okay? And how many columns are we getting? How many columns are we getting? So in this particular case, we're getting 2 columns, right? We're getting columns 1 and 2. So what we could do is we can use an inner colon notation, okay, and do 1, 2, colon 2. Okay, and that, remember colon notation, right? 1 begin, and the 2 default skipped is 1, right? So in this case, we're going to get 1 here and 2. Okay, so that would give us in turn, we get all columns, all rows, right? 1, 4, 7, and columns 1 and column 2. Just this is column 2. right? Using colon notation here. Okay. If I only wanted the first row, I'm sorry, the first column, then I would probably just do 1. So that's simple enough. That's simple enough. So here's a question which I'll let you take a little moment. How would I get the first and third row? Okay, I mean the first and third column, all rows. Okay, so essentially what I want is this. What I want is this and this, so that my resulting matrix is going to be 1, 3, 4, 6, 7, and 9. How would I do that? I'll give you about 10 seconds and trying to think about it. Were you able to figure it out? Okay, so in this particular case, do we want all rows? We actually do, because we want all rows of the first column and all rows of the second column. Remember, that's the question that you should be asking initially is, do we want all rows? Okay, and if you see that we need all rows, then you know that the first row parameter for colon notation is going to be colon, right? Because we want all rows in this particular case. So we're going to get all rows, but we only want the first and third column. So there's two ways to do this. I'm going to do it the kind of cool way, okay? And what you could do is you can, again, use colon notation inside, where you begin in the first column, okay? And we're going to skip 2 and end at the third column. Sorry, I don't know if you could barely see that, but let me do a better job of that. Let me do this. So maybe I can repeat it as well so you understand. So we want A1, okay? We want all rows, and we want the first column. We want to skip by 2, right? So from here to here, because we're starting at 1, right? We want to skip by 2. So my second parameter would be 2 here, okay? And then we end at 3. Okay, and you'll have another parenthesis here. By doing that, we're getting all rows, as you see here, right? And we're gonna get or extract the first and third, because we begin at 1 and we end at 3, and we skip 2, right? We're skipping skip 2. Right? So as you see here, okay, we skipped 2. Okay, so I was able to extract that and using a subarray. We call this a subarray. Okay, a subarray. And all this with the beauty of colon notation. Okay, the beauty of colon notation. Okay, on the next video, we're gonna take a look at this in MATLAB, and we can reference back to this example, these examples. And hopefully it makes sense, and then you can try some exercises on your own. I'll see you on the next lecture.